All right, what's up, AB people? I'm going to show you guys the derivation of cos inverse and tan inverse first, and then we're going to look at one, maybe two, probably one example of how to do a derivative of like these inverse functions. All right, so let's look at cos inverse first. So if you remember from class, right, the trick here was we we needed to first get rid of like the inverse function to kind of like come up with the what is it? The derivative, right? So we're gonna get cos y on the left. On the right, we're just gonna get x. Now, Mr. Lees, we have to do this every time you want to derive inverse? No, no. You just memorize it, essentially do the shortcut. But this is like the find how to find like what the derivative of the inverse is, right? So, like in class, we learned sine inverse is 1 over root 1 minus x squared. So you don't have to do this every single time, all right? Like what I'm doing, all right? So here we go. We're gonna differentiate this implicitly. We get negative sine y prime is equal to 1. And this is kind of mirrors what we did in class today, right? We're gonna get y prime. Instead now it's negative 1 over sine y. And using this definition here, we are going to create the triangle just like we did in class. I'm going to call this angle y, and it's going to be opposite over. Oh, wait, no, it's cosine. Cosine is adjacent over hypotenuse, right? So that means this one's going to be the 1 minus x squared, right? Because, Pythagorean theorem, like x squared plus, I guess, opposite squared is equal to 1. Then you get opposite is 1 minus x squared and the square root of that, okay? And now we just put it together. Sine of y, this y right here, is opposite over hypotenuse. So it's this right here. So what is the derivative of cos inverse? It is negative 1 over root 1 minus x squared. And that's it. That's cos inverse. All right, up next we have tan inverse. So let's do d dx tan inverse. All right, and well, I think I said it in class already. We should get 1 over 1 plus x squared. So let's prove it. Y equals tan inverse of x. Just like the other ones, we're going to tan both sides. So it's nice and crispy. Get it? All right. So tan y is equal to x. We know the derivative of tangent, right? It's going to be secant squared of y prime is equal to 1. Divide through, we get y prime is equal to 1 over secant squared of y. And this is the same thing as cosine, right? 1 over, no, just cosine squared. So we need to figure out, using this thing, well, we're going to make a triangle, how to get to cosine, right? So here's my y, tangent is opposite over adjacent now, so that's the difference. And 1 squared plus x squared is equal to hypotenuse squared. We get the square root of that, so it's 1 plus x squared. Cosine of y is going to be adjacent over hypotenuse, right? So, but this squared is going to do something for us. It's going to be adjacent, which is 1, over hypotenuse, which is root 1 plus x squared, quantity squared. And look, there it is. 1 over 1 plus x squared. And there it is. We got a derivative of tan inverse. All right, here we go. Up next, we are going to do a quick example, somewhat quick example, dealing with inverse trig. All right, let's look at, I'll call this example 1. We have y equals tan inverse of root x. All right, and immediately you guys see that there's got to be some sort of chain rule going on because there's a square root of x in there, right? So, you know, we can do this the long way, the short way, whatever you want. I'm just going to keep it as root x and just kind of imagine that and just like kind of think that it's there, you know? Like this is going to be like my blah, right, that I have to derive later on. But at the same time, this is going to be the thing that's going to be squared in our derivative, right? Because we just found that the derivative of tan inverse, it's going to be 1 over 1 plus x squared. So that tells you that whatever's inside of your tan inverse gets squared. So putting this together, right, this is going to be 1 over 1 plus root x squared. Does that make sense, right? So the thing inside your argument, the argument inside of your inverse trig function is going to get squared. And then since it's a chain rule, I have to multiply by the derivative of root x via chain rule, right? So this is going to become, what is the derivative of square root of x? That's 1/2 x to the negative 1/2, or putting it all together, 1 over, it looks like 2 root x times 1 plus x. And then you can simplify this even further and say 1 over 2 root x plus x to the 1/3. What is it? 1/2 plus 3/2. I'm not sure where 1/3 came from. And that's pretty much it. That's the derivative right there. So yeah, that's it. If you guys want me to do more examples or something like that, you know, just make sure you save the questions and I can go over them during class or whenever. All right? I'll see you guys soon.